Hello everyone, I guess we are live. Let me just check one moment. I'll just confirm the notification, then we'll start, okay? Just a moment. Yep, we are live. Okay, hello everyone, welcome back again to our channel Code Circuit, and this is Saurabh. Today again we are back with our Java DSA live session. Yes, so let me just write it down. Java DSA live sessions, and we are at Code Circuit. Fine. And guys, what were we doing till now? We were learning about binary trees. Okay, binary trees. If you remember and if you recall, yes, KS says good evening, sir. Yes, good evening. I hope everything is fine and my voice is audible. Okay, so yes, what I was telling, I was saying that we had discussed about the traversals. Okay, in the traversals, we had done one traversal, which was the DFS traversals. Okay, in that I had shown you all the three: pre, in, and post. Okay, and if you try to remember the shortcut, it was data left right, and it was in was LDR, left data right. This was LRD, correct. And in some books or some websites, you will get something like this. No need to worry, it is written like this: L, then root, then right, okay, left, then root, then right. This is left. Yes, sorry, no, my bad. This will not be here. Let me write it down correctly. It will be something like this: the node, the left and the right, the left, then the node, then the right, and then the left, then the right, then the node. Either you can call it D for data, N stands for node, anything is fine, okay, no problem at all, fine. So, what we will do is, this traversal we have understood, and if you remember, we had done something like this yesterday. Let me open the project. Yep, you can see here we had done that yesterday, right? The tree node thing. See, if you see here, we had done the pre-order, we had done the in-order, and we had also done the post-order. Everything was fine. And also guys, I showed you one more thing yesterday. What was that? It was this one, the generic tree version. Generic tree by using this syntax, T syntax, the template syntax. This is also available in C++. I have shown you that. Fine. Yesterday I could not attend the lecture, but I have seen the recording later. Very good, no problem at all. KS, I don't know your full name, but I'll greet you like KS only. So if you have any doubts after watching the video, please comment your doubts in the comment section. Okay, no problem at all. If you don't understand, I'll be very happy to clarify all your doubts. Okay, no problem. Fine. So what we do, guys, I had showed you the pre, in, post, everything in the DFS traversal, and then I showed you how to create a generic tree. Now today we will go to another type of traversal. This traversal is very easy, but there is a trick. Let's go to that. Now we will go to the breadth first search traversal. Breadth first search, or what is the other name, guys? Sometimes you will get this name, so never get confused. Okay, I'll just say level order traversal. So both the sides I'll write down the two names. Here it will be called BFS, or else in some questions you will get it written like LOT, level order traversal. Both are actually the same thing. Fine. Let's take the same example that we had yesterday. So I have 1, then I have 2, 3, and then I have say 4, 5, 6, 7, something like this. Okay, here now let's construct the tree properly like this. Okay, this is my tree, and if you want you can take this 2 also if you want. So, this is 9 and this is 15. Fine. Now, see carefully, I am taking a highlighter. This is level 0, this is level 1, this is level 2, this is level 3. Make sense? Now, level order traversal means very simple. Try to understand like this: top to bottom, left to right. This is first thing, then it is left to right. The third thing is level by level. Okay, these 3 things you have to remember: top to bottom, okay, left to right, and level by level. Got it? That is the simple idea about level order traversal. In that case, what will be the output? So, this is level 0, 1, the root node. Level 2 has, so if I write down here something like this: level 1 will have 1, level 2 will have 2, 3, level 3 will have 4, 5, 6, 7, level 4 will have 9 and 15, just for your understanding. Okay. So, here the output will be top to bottom. So, obviously from the root node we will start and we will go bottom, and it will be level by level, left to right. So, simple output will be in this case 1, 2, 3, 4, 5, 6, 7, then last level it is 9, 15. This same concept you will be using in graph traversals also, and this will be very handy when you are doing what is that called, the cycle detection algorithms. Fine. So, this you have to remember. I do not think there should be any doubts. Yes, all good. So, what I was saying is at that time try to understand. See this, here it is level number 0 and we have one node. Okay. After that you have level number 1, we have 2 and 3. Here we have 4, 5, 6, 7. This is level number 3, and then it is level number 4, 0, 1. So, it can be not, this will be 2 and this will be 3. You can number it like 1, 2, 3, 4 also. That is totally your choice. Okay. Hope you have understood this now. Any doubts you can let me know. Now, what I am saying is, try to understand this very carefully. Here, why is it like this? See, from node 1, these 2 nodes are at the same distance. See, same distance. That is why they are at the same level. From node 1, 4, 5, 6 and 7 are at the same distance. If you see 1, 2, 4, 2 steps, 1, 2, 5, 2 steps, 1, 3, 6, 2 steps, 1, 3, 7, 2 steps. This kind of feature will be used while you are going to graphs also. Here if you see, for say for example 9, 1, 2, 3 at a distance of 3 or unit of 3 you can say. Similarly 15 will be at a distance of 1, 2, 3. That is why it is at the same level. Understood why it is called level? Simple as that. Hope you have understood this. Now, how do you do this? Okay, let us try to understand how to do it. I will draw the same diagram once again. Now, you understood this part, right guys, how it is level like this. Okay. Now, let us try to figure out how to solve this. Okay. I will write it down once again: 1, 2, 3, then I have 4, then 5, then 6 and 7, and I have 9 and 15, right. This was it like this. So, is it something like the output means to be like this: 1, 2, 3, 4, 5, 6, 7, 9, 15. So, what did I say? Top to bottom. left to right and level by level, correct? Remember this. So in that case what should happen is, right now there are no doubts, all okay. So in that case what should happen? See, it looks like something like this. Once I reach the level, the first node that I get is actually printed. Once I get to this level, level 0, the first node will be printed. Once I get to level number 1, the first node that I encounter will be printed first. Then comes the second one. Got it? So that means the left node, see, always the left node is printed first. In each level, if you see the left node, in the first case root node there is only one node, forget about that. In the second one, 2 and 3, see, 2 is the left node, 3 is the right node. So 2 is printed at first, then 3 is printed. Same here in this case. 4 is printed at first, then 5, then 6, then 7. So what do you see? There is an order, left to right order. So always the left node is printed at first, then the right node. Okay. So we can simply take a queue data structure. Queue of what can we take? We can take node. Yes or no? We can take, and this will be an angle bracket, not a square bracket. We can take a queue of node, and initially we can push the front node. The current node or the node will be equal to root node. Make sense? The root node is 1, it is always printed. So 1 will be popped and printed. We pop that node and print that node 1. After that what will happen? We will go to the left first. So what we will do? I will say queue dot push node dot left. I can take a if condition, if it is not null, if not null. Make sense? Got it? Then again the same thing will happen, pop this, print this. Then I will take one more if node. Now it will say queue dot push node dot right. Make sense? For any node, first I will print the left side, then I will print the right side. That way I can easily do this level order traversal. It's as simple as that. Hope you have understood the algo. Sir, will pre, in and post order in BFS follow DLR, LDR? Nahi. It will not follow that. In case of BFS, there is no in order, pre-order, post order. It is simply top to bottom, left to right, level by level. Please remember that. Okay. So the output will be always, it will always be 1 first level, 1 second level, from left to right it is 2, 3, third level it is 4, 5, 6, 7, last level it is 9 and 15, 9, 15. So here if you see carefully, this is level 0, this is level 1, this is level 2 and this is level 3. This is the only output, there can be no other outputs. There is no in, pre, post in this. Okay, please remember that. Hopefully it is clear. Just give me a thumbs up or okay if it is clear or not, and you have understood this. What we are doing, we are pushing the front node, q dot front equal to, we are always writing the left side. After that we are going to the right side. Got it? Makes sense? If it is clear, then we can just go and write down the code. Okay, there is no in, pre, post in the BFS. In, pre and post is always there in the DFS traversal. Okay, so hopefully you have understood this. Now let's go and write down the code. Okay, all of you, is it okay? If that's okay, then let me know, then we'll start the code. Hopefully KS it is okay. Now what I'll do is, I already have this one. Here you can see I had the DFS. Now let's write down this one. I'll take a new Java class. This time I'll write, say, binary tree. This is my class, and here what I will do is I'll write something like this. Let's take the class tree node. Yes, very good. Everyone says clear. See the syntax what I am writing. Okay, and this is very simple what we are doing, and the code will be easy also to understand. Int value, I am taking the value, data, value, variable, whatever you want you can take. I am taking the left, I am taking the tree node right. Okay, and then let's take the constructor bracket int val, or let's say x, whatever it is, it doesn't matter. I'll say value equal to x, In this kind of syntax, you don't have to write this keyword, not required, and you can write left equal to right equal to null pointer. Okay. This template prototype you already know. I think everyone know this. This is not new. This should be null pointer. Okay, not new. This is fine. This we know. Now, this is my node structure for each node that we are going to create in the tree. Now, here in the binary tree class, what I will do is I will create this thing level order traversal function. Okay, so let's write it down. Anybody? I think everyone is fine with this. So let's write it down, and I don't want to create an object. So what I'll do, I'll write static void level order traversal, and obviously I will need access to the root node only. And base case, always remember the base case is that if the tree is null, we will never traverse the tree. Okay, so I'll just write down base case. If the root is null or the tree is empty, we don't traverse. That means we will just return. If our root is equal to null pointer, don't do anything, just return. Okay, return to the calling function. Otherwise, we need a queue, right? Queue to store the nodes. This queue will be not of int data type, it will be of the node data type. So, I will take a queue, see queue I am taking like this bracket tree node. Okay, queue is equal to new. I can take a linked list also, doesn't matter. Okay, this is the syntax. Now what I will do, as I said, first thing is just to see what I am doing here. I will always have to add the root node. Okay, so I'll just say q dot push why is it not giving me the suggestions? Q dot, yes, now it is showing me the suggestion. Okay, pu, sorry, it is add, my bad. Stack is having the push method. Q dot add, what do I need to add? I will add the root node. Why? Because we always have a single node at the root. Okay, single, makes sense. And what we are doing, see, in some cases what will happen is there will be a single node. Try to understand, even this is also a tree, one, there is nothing else, leaf node, in that case there is only one node. What will be the output? The output will be one only, correct? So I will write something like this, while my queue is not empty, I will write the not operator here, and what we will do, I will take a temporary node is equal to q dot the front element, that is pole. Okay, we have done this. Now I will just print that value, node dot val, the value I am printing, and let us give a space also. Fine, this is clear everyone. Now what you will do after that, first I need to go to the left, then I need to go to the right. So there will be two if conditions. Let me just say left subtree. Okay, I will just say if our node is node dot left, obviously if there is a left subtree, imagine this is not there, imagine this is not there, but this is there, then this I will not go this side, this side is invalid, I will not go, only go this side, right? So I will write a if statement like this, if my root dot left is not equal to null, then I will go to the root dot left, right? So I will add q dot add what, root dot left, make sense? Okay. Similarly, there will be a right subtree. I will write if our node dot right is not is equal to null, what we will do, I will just say q dot add node dot right, okay, and I think that's it, that's the code. And see here we have written a system.out.print. Let's write a print here, and after this loop is over here, what we can do is we can just print an empty print statement so that the control goes to the next line. Fine. Now this is the code, is as simple as that. Hope you have understood this. ठीक है, अभी क्या करेंगे, let's go and write down the main function, create our tree. Okay, let's create the tree. Top to bottom, I'm just writing it down, bottom, left to right, level by level. Okay, so this b, let it be capital only. Okay, so I'm just saying tree node root is equal to new tree node 1. Okay, and this is not rot, okay, my bad, sorry. So it will be root dot left is equal to new tree node 2. Okay, root dot right is equal to new tree node 3, and let me write 4 5 6 7. Okay, also, so this will be 3, and root dot left is equal to new tree node 4, root dot left dot right is equal to new tree node 5. This will be right dot left and right dot right. Root dot right is equal to right dot left first, tree node 6, and root dot right is equal to new tree node 7. Okay, so this is level 0, and then what happened to this? Okay, this is level 0, this is level 1, and level 2, 0 1 2. I have 3 levels. Let's if you want to write this 2 also, then we can write that 9 and 15, root dot left dot right dot left. So this will be level 3, root dot left dot right dot left is equal to new tree node. This is 9, and the last one, root dot right dot left is equal to new tree node. What is this? 15. Okay, now let's just call this method and see if it is working or not. Okay, so s out, sorry, my bad, just a moment guys, s out, yes, or BFS level order or BFS traversal, call the level order traversal, pass the root node. It should be 1 2 3 4 5 6 7 9 and 15, right? Let's verify. Wow, it's not stopped, so we have not done something here. Let me just check. One part, can anyone tell me what we are not doing? We are not removing an element. Can anyone tell me what we have done wrong or something? Anybody? See what we are getting. We are getting a constant value. It is continuously doing this. Why? This is wrong, right? This should not be happening. What's wrong here? Can anyone tell me? Look at the code and tell me. The base case is correct. We have added the root node, everything is fine, and this b should be capital. Let's debug this. We are removing that, that is fine. Node dot value is printed, fine. This is also fine, all good. Anybody, can you tell me what's wrong? Let's see who can tell me the output. Here I think root dot left, root dot right is fine. Left dot left, left dot right, right dot left, right dot right, left dot right dot left. See, left dot right dot left and right dot left. This is also fine. Can anybody tell me what is wrong? Let's see who can tell me this. The base case is root equal to null return. This is fine. New linked list. This is fine. Q dot add root that we have done. After that, while q is not empty, we are storing this here. Node dot value. Anyone? Can anyone tell me? Let's see. I'm not getting any messages. See the code and tell me what's wrong here. Anybody? Just waiting for you. Let's see if anybody can help me rectify this. Nobody is saying anything. Q dot poll, this is fine. Plus this is fine. Not equal to null. Node dot left. Right subtree, this is also fine. Anybody? Can you guys tell me what is wrong? Why is it not printing correctly? Look at the code and tell me, because this is very interesting. We should not be getting something like this. See, it is giving like this. See, this is not a correct output. It should not happen like this. Why is it doing this? Anyone? Let me import, optimize the input. Still waiting for your answers. Anybody, if you know. Q is never empty. Yes. So what should you do? Tell me. Anybody? Very good. One rectification you have done. Q is not empty. So what should you do? But this should remove that, right? This should remove. The poll method, if you see here, retrieves and removes the head of this queue. It should always remove that. It should work. Why is this not working? Have I taken a wrong queue here? No, it is the correct queue only. Why? Tell me, anybody. Can you tell me? This is fine, everything is fine. This tree node, let me just check. BFS, okay. This one is from BFS only. I'm just checking if I have imported any wrong classes here, okay. That's what I'm just trying to check. Remove visited nodes. I think condition is always true. Are you sure? Or here you can check. Let me check this thing also, the tree also, because maybe root node is this, root dot left is 2 and root dot right is 3, left dot right is fine, right dot right is also fine. But it should not be working like this. It should give you the output. Let's check and see if this base case is also fine. Root is equal to null. No, it's not like that actually. It should be working. I don't know why this is behaving like this. Because see, the concept is simple. When we use the poll function, it should retrieve and removes the head of this queue. or returns null if this queue is empty. It should work. Why is it not working? I think condition is always true. You guys are also saying the same thing, but I am also trying to figure out if this works. This should be working. Because otherwise we could have used any other function also. We have used poll function, so it should remove. Observe carefully, guys, just observe carefully. Why are you not able to figure it out? See, I'll tell you one thing, just I'm giving you a hint, very important, okay? This is called the most important thing. Observe carefully. See, in your most of the interviews you will get a very important factor called debugging. And also there is something called this, what is this called? Yes, pseudocodes. Look at the code carefully. I'll just pause it here, try to understand. Look at the code properly and tell me if there is any mistake here. Look at the code, forget about everything else, just look at the code. Have you figured out? Very good, you got it. So see, this debugging thing is very important. This will fetch you extra packages. That's very important, and this will be given in pseudocodes. You have to find the output. Sometimes the output will be an infinite loop or something like this. See what actually KS has told. What I am doing, it is node.val, that is fine. After that, what am I adding here? It is root.left. This is wrong, absolutely wrong. This should be node.left. That's why every time it is giving an infinite loop. Now see, if I run this, make sense? Okay, hope you have understood this. There was nothing wrong in the code concept. The thing is that when I stored it here, only thing was I wrote root.left here. This is not root. When I am storing the current in the node, it should be node.left, right? Okay, hopefully everything is clear now. Everyone has understood this. Any doubts, you can let me know. Yes, at least KS could figure it out. Got it? See, here I had written correctly, here it was a mistake. And it's very important to rectify the mistakes also, then you'll understand. Otherwise, what I would have done is, I would have written a print statement here. Before this printing, I would have written a print statement here. S out the whatever it is, the value. Print something. Then you will automatically know whether it is reaching that part of the code or not. If it is not reaching, means there is something wrong here. That is how you can figure out. The best form of debugging is writing print statements. Please remember that. Okay? Write some print statements. That will really help you in your code. Anywhere you have that, you will understand that. Hopefully now it is clear, the code is clear and everything is fine. Okay, you got the output. See, look at the output again. If I run this again, let's see, it should be 1 2 3 4 5 6 7 and 9 and 15. Okay, got it. Now it is coming absolutely like the way we want it. All good, all set. Let me know if it is clear or not. All clear, right? So now let's do one thing. Let's move on to some interesting interview questions. Okay, in the meantime, let me just check if there is any comment. Not yet, everything is fine. So what we can do is, we can move on to some interesting questions now. Okay, all good. So let's go to some questions. Yes, KS successfully found out the mistake that we had made. Fine, great. And yes, Siddharth, the queue is empty, and when we use the poll method, it is always empty. Okay, the question was not about the logic. The question was about the mistake was about this. I had written root, it should be node. Okay, all good, I guess. Fine. Now let's do one thing. Let's write some interesting questions. There are lots of important interview questions on trees. Okay, and let's talk about some of them. Yes. Mirror of a binary tree. Very interesting question and very important question. See the code or see the question. I have 1, 2, I have 3, and then I have say 4, 5, 6 and 7. This is my tree that I have right now. This is the original tree. Then I have, what is that? The mirror tree. The mirror image will be exactly like this, but a mirror image. So it will be, this will be 3, this will be 2, this will be 7, this will be 6, this will be 5, this will be 4. Okay. How do you solve this? Anybody? Can anyone help me out on this? This has been frequently asked in most of the interview questions. You have this for Amazon also. You will get this for Accenture also. You will get this for LG Soft also. Many interviews have been asked on this topic. Mirror of a binary tree. How do you solve this, guys? Anybody? If you observe carefully, the root node is intact, not changing. The root node is same. Correct? Only what is happening, the right tree, the right subtree is becoming the left subtree. The left subtree, the left subtree is, the left has become the right has become the left. Okay, here if you see, this was here it is a left, correct? In this case it is a right. Extreme left, extreme right. How do you solve this? Anybody, can you tell me? This has been asked a lot in interviews. Just waiting for anybody to answer. How do you solve this? Can anybody tell me or give me an idea of how to do this? Just like we have variables 1, 2, say a is equal to 1 and b equal to 2. How do you swap them? Here they are getting swapped, right? Correct? The subtrees are getting swapped. I can say temp is equal to a is equal to b is equal to temp. Makes sense? So in that case, a will become 2, b will become 1. Correct? Can we use some similar logic here? Is it possible? Anybody? Can you tell me? Is it possible to use something like the same here in this question? The mirror image of a binary tree? Possible, not possible? Just let me know about that. Just waiting for you guys to reply. Swapping, yes, very good learning. Swapping. How do you write this? I can take a tree node root is equal to root dot left. and I can write root dot left is equal to root dot right, and root dot right is equal to this one. Rather than writing root, I can take a temporary variable. Let me delete this line. Okay, see what I am trying to do. I am writing here, say root dot right equal to temp. Can I write like this? Temp equal to root dot left, root dot left equal to root dot right equal to temp. Will it work? Should work. At each level, reverse the numbers. It's not about the level, it's about, see, everything is getting swapped. The whole tree, this whole subtree has gotten swapped. See, it has come here, and even in that the left has become right. So for each node you have to do it. Okay, for each node, suppose I have 1 2 3 also, everywhere I have to do this. Okay, so for corresponding nodes I have to do it. For one, the left the left becomes the right becomes the right. Okay, let's try to write this, then we'll figure out what are the things we get. Very good. KS says recursive call. We'll talk about that. See, let's write down this and let's see how it works and how it goes. Fine. So I'll close all this and let's write it down something like this. Okay. So BFS is done, DFS is done. I have questions, and here I'll create a new package called mirror tree, and here let's write down a new Java class. Right click, new Java class, say I'll write tree, something like this. Okay, and here I'll have the data tree left, tree right, and then I'll just say constructor bracket int data, this dot data is equal to data, and this dot left is equal to this dot right is equal to null pointer. Okay, this is the normal template that we have. Now I am writing this. Okay, but yes, good question here, guys. How will you figure out that it has actually been converted to this? How will you actually figure out that whether this tree has actually been converted to its mirror? How do you check that? You need to check that, right? You need to verify that. How will you do that? I will give you an idea. Take the Inorder. Take the Inorder. Tell me the Inorder, both of them. This is 4, then it is 2, then 5, then 1, then 6, then 3, then 7, correct? In this case it should be how much? 7, then 3, then 6, then 1, then comes 1, then it will be 5, 2, 4. If you check carefully, this Inorder and this Inorder are exactly reverse of each other. Check carefully. 4, 2, 5, 1, 6, 3, 7, 4, 2, 5, 1, 6, 3, 7. See, have you understood? So we can validate this, that my Inorder traversal can easily tell whether the original tree has been converted to a mirror tree or not. That means first we will create a method called mirror tree, where we will pass the root node, we will do the swapping, we will check whether it has been converted to a mirror image or not. By how? We will do the Inorder for the original tree, and then we will do the Inorder for the mirror tree. If both are reverse, then actually we have got the correct output. Okay, hope this is clear now. Any doubts, you can let me know. All good? I hope this is good. See the Inorder properly. See, that is why Inorder is very important in some cases. Okay. So, let us write down the code now. Private static void root node. So, I will just write if our root is not is equal to null, Inorder root dot left. Okay, then we will print the data. Let me remove the ln, and here we can write root dot data plus we can give a space. Okay, guys, I need your messages regarding whether you have understood this thing or not. If yes, then please just ping a message by saying yes. Okay, so this is our Inorder, and then I will just go to the other side, the right side, root dot right. Fine, this is our traversal done, and then this finishes our Inorder function. Now we will write the mirror tree logic. So, public static tree, it will return a tree. Okay, it will take the original tree and return the mirror tree. Root position remains in middle. Yes, definitely it remains in middle. Tree root. Okay, here base case. The base cases are very important. If the tree is empty, do you need to do a mirror image of null and null? Null and null will be same only, right? So, you do not need to do it, just return. Okay, I can write down something like this. If the root node is equal to null, you can simply return null, because the mirror image of null is null only. Fine. Otherwise, we have to swap the left and right subtrees. Okay, let us write down like this. See, the swap the SWAP, swap the left and right subtrees. So, here we will take something like this: tree temp is equal to root dot left, just like temp equal to a equal to b equal to temp. Root dot left is equal to root dot right, root dot right is equal to temp. Okay, temp equal to a equal to b equal to temp. This is fine. Now we can see return the root node, because the root node is the way we can access this. Correct. Now let us go back to our main function and try to call this. We will just say tree root is equal to new tree. This is 1, and tree root dot left is equal to new 2, root dot right is equal to new, this is 3, and let us write down the others also. Root dot left is equal to, this is 4, root dot left dot right is equal to 5. Okay, let us drag it up, and then root dot right dot left is equal to, this will be 6. Okay, and root dot right is equal to tree node, this will be 7. Make sense? Now I will just say S out in order of original tree. Let us remove the ln, and let us see here what we have written. I think we have written print only, that is fine, and let us call this Inorder traversal and pass the root node. Okay. After that, let us go to the next line, and then I will just say root node. The return type of that method that we have written is root. See, if you see tree mirror tree, so it is returning a tree. Okay, I will just say root equal to mirror tree, pass the root node, and then I will copy this whole thing again, copy and paste it. Okay, this time it will be mirror tree. Do you think this code will return the output? I have swapped the left and right subtrees. Will it return? See the output and see what is happening. Is it working, guys? Is it working? Carefully observe. 4 to 5 came this side, 67 came this side, but is it what we were expecting? 4 to 5 not like this. Is it exactly reversing? No. What is actually happening is, let me take a highlighter and show you. Yep, here this part has come here, good, this part has come here, but actually the recursive swap has not happened. Okay, see, 4 was here, 4 should have come here, correct? In our case 5 was here, 5 should have come here, but is it happening actually? 4 to 5 directly has come here, it should be not like this, 5 should come this side, 4 should come this side. What is not happening? Anybody, can you tell me? Just remember one thing, very important, as many of you have already suggested here, I will just tell you one thing. Please remember, 80% of your interview questions on trees and graphs will be solved using recursion only. If you do not do recursion, what will happen is only a part of the tree will be swapped. That means this is going here and this is going here, not okay. Everything should be swapped, okay. Every left subtree will become a right subtree, every right subtree will become a left subtree. So, just remember, more than 80, you can say 80 to 85% of interview questions on binary trees, and sometimes it can be heaps also and graphs also, will be solved using recursion also. If you do not use recursion, you will only get a partial output, okay, make sense. So, what you should do is, see what this is doing is, this is only from the root node, it is keeping this side and this side. That is not the case. I need to do using recursion also. So, this is a node, from here 6 should go this side, 7 should go this side. How will this happen? It should happen through recursion. See, that is why I left the space intentionally here. See, if you see carefully, I had left a space. See, before returning I had left a space. So, what we did, left and right subtrees have been swapped. Now, we will swap the children recursively. So, I will say recursive swap for the children as well. So, how do you write this? Children, DREN. How do you write this? I will say something like this. If there is a root dot left, you can say not equal to null, pass the whole left subtree into the mirror tree function again. So, you can say mirror tree root dot left. What this will do is, this will reverse the whole thing at the left hand side, okay, the whole thing. Similarly, after this we should do it for the right one, right. So, if our root dot right is not equal to null, then swap it recursively by calling it to the root dot right, okay. So, root dot right. After that you can return it, okay. This is very important. Now, let us do one thing, let me right click and run this and let us see if it is working or not. Hopefully, this time it works. See guys, 4251637, this time it is 7361524, okay. This is how it works. Hopefully, you have understood this. Very good learning. One more recursion should be done. Absolutely yes, we have to do it, because otherwise we will get a partial output, and this will pass only some test cases, some will not pass. Say, I will tell you one reason where it will pass. In some cases, say suppose your code or your tree is like this 1, 2, 3. In that case, this is fine. This will become 1, 3, 2. Absolutely okay, right? No problem at all. This is working. But for a longer tree which has more depth, the tree which has more depth or height, you can say, in that cases it will not work. So, only if there are 2 levels, in that case it will absolutely work fine, but for other cases you have to use recursion only, okay. So, multiple test cases might pass and multiple might fail. So, make sure you use recursion for all of them. Hopefully, you have understood this. All good, I guess, right? Now guys, I'll tell you one thing very important. We have seen one question. Now I'll just write down some important questions that you need to understand. We have seen mirror tree question. Now there is something called identical trees. Then we have height of a binary tree, height or depth of a binary tree. Then we have diameter of a binary tree. Then guys, we have something called lowest common ancestor. Okay, LCA. Then the mirror tree function that we used can be used to solve a very important question called symmetric. Why did I write this kind of a SYMM symmetric binary tree? Okay, these are some important questions that are frequently asked in the interviews. And yes, you have two other questions, left view and right view. These are also important. So if you study these questions, these are more than enough for what? For binary tree concepts. And yes, there is one difficult level question also, that is, I guess, what was that? Serialize and deserialize a binary tree. And all of these questions, most of the times you will be using recursion only. So you should be very good in recursion if you want to master binary trees. Okay, this you have to remember. Okay, so if you want, you can take them down. These are very important things. You can simply take a screenshot of these questions. If you study these questions, these are enough to handle all type of questions on binary trees. Okay, and definitely we will be discussing most of these questions in our live sessions only. Okay, so yes, hope this is clear and there is no doubt. Anybody has any doubts, you can let me know. Guys, please remember these questions. These are some medium level, hard level questions from lead code only. You can take them down from here. Okay, and you can practice them. If any doubts, you can let me know. Okay, yes, out of this, not like they can randomly ask you any question. Okay, so make sure you practice all these questions. And there is one, what to say, I have given you this one, right, website. It was 450dsa.com. Here you will get a lot of interview questions on binary trees. Okay, if possible, make sure you go through them one by one. Okay, so I hope you have understood this. Today we have covered one important concept, that is level order traversal. I'll write it down here, LOT, or it was BFS. Okay, this we have understood and learnt. After that, what did we do? We learnt about one important question, that is the mirror image mirror tree. And then I have given you a list of questions. Guys, binary trees are still there. There are lots of questions to be done. We will be doing this one by one. Don't have to worry about that. And let's see if I can come live tomorrow. Definitely I will be coming around the same time. Don't have to worry about that. We will do that. If possible, I might come a little bit early. Guys, I want all of you, those who are watching, to tell one thing. Service based companies ask more questions in coding rounds. Service based topics, good question. See, most of the times you will have questions on these topics. Let me just, sorry, the ruler should not be coming here. For service based companies, It totally depends. See, right now they will be offering very less packages compared to the product based companies. Still, most of the times you can focus on graphs, trees, and then obviously arrays is very important. This is common, and then strings will also come. And at the same time, if you want DP, I don't think these companies ask a lot. They don't ask, but graphs and trees are important. That's why I've given you in a order. After that, some important algos they will ask. Okay, the algos I had given you that day, if you remember. Euclid's algo. Then I had given you the cadence algo. Then there is something called sieve of Eratosthenes. Okay, these are some important algos, and there is one string algo called the Ravenkap algo. These can be asked, so make sure you remember them. And also for service based companies, binary search is also an important concept. Binary search applications, where can you apply this? If you cover these many topics, your service based companies interviews concepts will be over. After that, yes, it depends on your department, the department or your domain where you are studying. Okay, then it will be computer networks, operating systems, and then obviously the OSI layer, this will be asked. And like for EC department and all, you should know about very well about the protocols and all. This layer is very important. Okay, the 7 layers, I'm talking about all the 7 layers. Okay, these things you have to remember one by one, very important. Okay, all of you please remember and try to learn all of them one by one. And yes, any doubts, obviously I'll be there to help you out, don't have to hesitate about that. Okay, so yes, we have understood about the binary trees and we have solved 1 or 2 questions, not more than that. Yes, next class what we will do is we will cover up some of the questions that I had given you earlier. Okay, fine. And yes, if possible I'll come live tomorrow also, and if needed you guys have to give me a time slot, not here, after the video ends. If you guys really interested in me taking one class tomorrow for interview questions on binary trees, let's do one thing. I'll give you 2 slots. One slot is say 4 to 5, this is one slot. One is 5 to 6. This too, because tomorrow is Saturday, I'll have a class in the evening. So 4 to 5 or 5 to 6, if you let me know, then I can take a class on any one of these 2 slots, 4 to 5 or 5 to 6. Okay, you have to comment in the normal YouTube messages. Okay, if I see this, based on that, if I get good response, then I'll definitely come live tomorrow also. Fine, okay. So Accenture interview completed 6 months ago, still results not published. Yes, it is very bad on the part of Accenture. They do this. Many of my students have said the same thing. Yes, the point is that sometimes they take it can delay up to 9 months, 10 months also. But after that also some students have got the the welcome letters or the joining letters. Yes. So in that case, just have to be patient and wait. You cannot do anything because they will not be giving you any contact number. They just be giving you a mail, right? A mail saying yes, you will get a the further information will be given via mail only. That is what you have right now, and you cannot even reply to that mail. Okay, so be patient and wait for it. Otherwise, most of the times, if it takes more than 9 months, also that means you have not been selected. That's the bad part, but they should be at least giving a message. I don't know why they do something like that, but yes, that is the only way you can do it. Okay, fine. So guys, you have to tell me if it is okay. But please remember this, you have to learn properly. This is again recursion only, and this is something like sub array problem, and this is about the prime number logic. Please study this. Any doubts, let me know. We will learn this in the classes itself. And this one I have already told you in the DSA live sessions only. Okay, you can go and watch them. Okay, And yes, trees is not over, we will have to do lots of questions, and then we will be starting with binary search tree. Okay. Based on this, let me know 4 to 5, 5 to 6 if you need a class. Okay. I will definitely come and take a live session also. Fine. So, thank you for watching, guys. If at all you have any other doubts, please comment them in the comment section. I will be very happy about that. I will be clearing all your doubts and try to help you as much as I can. Okay. So, for the time being, I will be taking your leave. Hope you have learnt a lot today. Yes, and thank you for watching, guys. If you're new to the channel, please subscribe to the channel and hit the bell icon so that you get a notification once we come live or you have any latest video published in our channel. Okay. Thank you, guys. So, till then, till the next live session, this is Saurabh signing off. Thank you and bye bye. Okay. Happy learning.